Hello everyone, this is Hybrid Accounts. Welcome to Quantitative Techniques or Quantitative Methods lesson. And today's session is on linear regression and correlation analysis, right? Of course, we'll start with correlation analysis, right? Okay, so actually we'll be dealing with linear regression and correlation analysis. And so actually we'll have to take a look at several things like scatter graphs, correlation analysis, as well as regression itself. So what is correlation? Correlation is simply the degree of association among between or among variables. Let's say you have two variables x and y. How does x change when y changes? Or how does y change when x changes? The degree of correlation. Maybe when x changes by 100%, y changes by 90%. Something like that that gives you the correlation, actually the association, the degree of association, right? Okay, so that's why you say correlation is a statistical analysis which measures and analyzes the degree or extent to which two variables change with reference to each other, right? Simply speaking, correlation does not indicate cause and effect relationship. Actually, it does not attempt to establish an equation between two variables, two more variables. No, it just actually explains the degree of association between two variables. All right. And so correlation is not always a result of logical reasoning. Sometimes you might be having some two results and then you determine the correlation, you find out that they are correlated. But actually it might be it might arise just due to pure chance. So actually you have to be very careful on whether you confirm that there is correlation between variables, and there are several ways that we'll see later, right? Yes, so just something like that. When determining correlation, we usually determine something called correlation coefficient, which is a pure number, actually meaning that it is unitless. And we'll also see the range, where it ranges. Usually it ranges between -1 and +1, something like that, right? Okay, and so have note that correlation can be positive or negative. By positive, we mean that when one variable increases, the corresponding variable also increases. When it decreases, it also decreases. But when we speak of negative correlation, that's what we say. If it is positive, it means that variables move in the same direction, right? But in case the correlation is negative, it means that when one variable changes by increasing, the other variable will change by decreasing. That's why we say it is negative when variables move in opposite directions, meaning that there is an inverse or adverse relationship, something like that, right? We'll see the examples too and the graph, so don't worry about that. All right, let's take a look at the degrees of correlation. Now, when dealing with correlation, it might have several degrees, right? The extent it could be positive, it could be perfect, it could be partial, but also there could be absent correlation. By perfect, we mean that when you plot them on the scatter graph, all the points will lie on the line. While when partial, not all the points will lie on the line, and this is a common thing. And then there could be no correlation whatsoever, no correlation at all. So you can just see explanation below. All right, when speaking of the perfect correlation, it's something like this. If you take a look at this graph below, you have to see everything. Do you see this? For example, here, I drew meters against centimeters. Did you know 1 meter equals to 100 centimeters? So it is obvious that when you plot the graph, all the points, you see the first point, the second one, the third one, the fourth one, and the fifth one, all the points are lie in the straight line, something like that, right? That's why we say there is a precise linear relationship between the given variables. Just something like that. Changes in one variable lead to proportionate change in the other variable. Proportionate, meaning that if one variable changes by 60%, the other will also change by 60%, regardless of whether it is positive or negative. It could be perfect, and also at the same time it could be positive or negative. For example, this one is the perfect positive correlation because, as you see, when x-axis increases, the y-axis values also increase. But also, it could be perfect, like you see here. This is for the law of demand, which usually compares price and demand. The demand, is the price. When the price falls, the demand would increase. So as you see here, when the price was here, the demand was here, and then when the price fell to this point here, the demand increased. So, but also if you take a look, we find out that all the points here are still lying in the same line, right? I hope you saw that. I hope you saw that. You can just see it here, right? The first point, the second one, the third one, and so on and so on. And you can see that when the price was here, this was the demand. And then when the price was here, this was the demand. You see, when the price falls, the demand increases. So there's an inverse relationship. And so if you have such kind of correlation, it also signifies the perfect correlation, but now it is negative. So when you have a negative perfect correlation, correlation coefficient denoted as R should be equal to -1. And when it is perfectly positive, it should be equal to +1, something like this, right? Yes, I hope you got everything. All right, now let's go to partial correlation. Now correlation could not be 100%. But when one variable changes, there happens a disproportionate change in another variable. Let's say when one variable increases by 60%, instead of the other increasing or decreasing by 60%, it maybe changes by only 50% or 40%, something like that. That's why we say there is no precise linear relationship between the variables. And also, when one variable changes, it leads to the disproportionate change in the other variable. That means they do not change by the same extent, something like that. You can just see examples here. For example, let's say maybe you're comparing the mileage of the car increases and the roads become smooth, right? Of course, when the road is smooth, actually your car can move for much longer, right? For a much higher distance. So something like that. So mileage against road quality, if the quality increases, the mileage will also increase. But as you see now, not all the points lie on the line. For example, we only have this point one and this one. The other 3 points are out of the line, something like that, right? Yes. And so you can have a partially positive correlation because all variables are increasing. When one increases, the other also increases. But still, the correlation could also be partial, but still negative. When one increases, the other decreases. For example, it could be maybe demand and temperature. Let's say maybe you're speaking to the demand of wool. Demand of wool would fall if the temperature increases, right? Because if temperature increases, actually if temperature increases, there would be no need for clothes to keep you warm. So it should be like that. So as you see, some points are stay in the line, but others are above and others are below the line. And then there could be absent correlation. When we say absent correlation now, we go up and say that there is no relationship whatsoever, no correlation, no association at all. For example, if you see here, we have variables y and x. When y is here, you can see this and get the complete picture of what we have to say. Like you see here, when y equals to this point, x equals to this value. At the same time, when y equals to this one, x equals the same value. See this? But also, when y equals to this, x could be this one or could be this one. 3 different values of x for the same value of y. So it means that there is actually no correlation, right? Something like that. So correlation coefficient here would be expected to be equal to 0. So variables are not at all related, something like that, right? Yes. So you got to know something like that. So putting this in a summary, we say that correlation is perfectly positive when r equals to 1, positive 1, I mean. Perfectly negative when r equals to -1. R means correlation coefficient, and it is partially positive when r lies between 0 and 1. Between, not inclusive, exclusively, and partially negative when r lies between 0 and -1. And correlation is absent. There is actually no correlation if r equals to 0. Right, something like that. So I think that was something important to note, and that all is well. All right, and now we can just go further and take a look at further elements. For example, here you have to see the properties of correlation. Now, how do we deal with these properties of correlation? We are going to see this later.